One moment. Let me pull it up.
Okay. So something you can verbalize, or do you need to send me pictures?
I'm going to send you a picture.
Okay.
One moment.
Mhm. Yeah, it was bad. I couldn't even access my schedule, so I didn't even know what appointments I had when.
That's weird.
Yeah, it's like you're totally off the grid when that happens.
Okay, I'm going to send you two pictures.
All right. Tell me when they're sent.
All right. I'm attaching the photos right now. Okay, I sent one.
Got it?
Yes, I sent one. And then here's my second one. Pretty much it's all of that page, page 11.
Okay. We'll start with 1.
Yes.
Okay. What's the domain of that function? Number 1.
Can I use my calculator?
You don't need your calculator. In fact,
Okay.
please don't use your calculator. I mean, if you have your calculator will give you domain and range.
It does the graph for me and I can look at it.
Well, that's one way to do it, but let's do it without looking at a graph. First of all,
Okay.
what does domain mean?
Everything on the x-axis.
Okay, it's basically is what values can x be? Well, in number 1, are there any restrictions to x?
No, it's from negative infinity.
Yeah, so it's all real numbers. What's the range? On the range, there is a restriction because what we
One.
have is we have y equals 1 plus x squared, and that's always positive no matter what x is. So what's the minimum value of y?
Um,
When,
negative infinity.
no, when x, no, because remember, if x squared is always positive, we're taking a positive number and adding 1 to it. So what's the least amount that that could be?
One.
0. And then the whole thing can be 1. So y has to be greater than or equal to 1. That's the range.
All right.
You see why? Now, if we graph that, what that is, in other words, the parent equation is y equal x squared. This is shifted up by 1. So there's the graph. Okay, it's a parabola. And if you look at that graph, you would figure out also that the domain was all real numbers, although it's not as clear that the domain is all real numbers here. In other words, does this really go all the way to negative infinity and positive infinity? And the answer is yes, it does. But the parabola itself doesn't make that completely clear. But in terms of the range, you can definitely see that it never goes below that point, which is 1. And it goes up to positive infinity on both sides. So I would say these exercises are designed for you to calculate the domain and range without looking at the graph of the function.
Okay.
I might be wrong, but yeah, because see, the next part of these questions deals with the graphs. You want to be able to figure out domain and range from the function itself. So the second one, we doing every one or just odds or?
We can do every other one.
Okay, let's not do this one then, since that's the next one. All right, now, what are the restrictions on the domain? What can be inside the absolute value? Can you have a negative number?
No.
Okay, so the way we solve this is we take whatever's inside the radical sign and we make
Make it a
sure that it's greater than or equal to 0. And then we solve that. So what's the solution to this?
-10.
You got to divide by 5 afterwards.
Okay, you don't want to get the 10 on the other side?
Well, you do. I was just
Okay.
doing it in one step instead of 2 steps. So that's the
Okay.
step, and then x is greater
X equals
than,
1 or equal to -2.
that's the domain. In other words,
Okay.
if x was -6, then we would have to take the square root of a negative number. So you can't have x be less than -2. Otherwise, that's always going to be the case. Now, you can take the square root of 0. There's nothing wrong with that. So that's why it's greater than or equal to. But whenever you have these kind of problems, that's what you want to do, is you want to take whatever's inside the radical and set it greater than or equal to 0, and then solve for x. Okay, so that's the domain. Now, have they taught you to write the domain in like interval notation?
Yes.
In other words, that is -2 with a bracket, not a parentheses.
Comma, infinity, parenthesis.
Parentheses. Infinities always have parentheses around them. The other numbers, it depends on whether it can be -2 or not. And in this case, -2 is okay. In other words, we would then be taking the square root of 0, and that's okay. So the -2 has to have the bracket.
Okay.
Okay. How many do we have to do today? Are you supposed to just decide, or did you just say that because we have so many to do, or?
I just said that just because of how many there is to do. I'm just trying to do as many as I can to study.
Okay. Well, let's look at 5 then. Odds are fine. I have no problem with just doing the odds. And then if we have time extra at the end, we can go back and do the evens. Okay. Now, what's the restriction? What's the domain here? What variable?
T.
Yeah. Domain is t. Range is f of t. So what are my possible values for t?
Would I have to equal it to 0?
Well, usually when you're talking domain, most numbers work, okay? So what you really want to see is what can t not be equal to? Well, in this particular function, t can be almost anything except one number. What's that number that it cannot be?
A negative number?
No. 3. And the way you get that is the very first rule of mathematics is you cannot divide by 0. Okay? So the way I'm going to solve for domain here is I'm going to set the denominator equal to 0 and solve it. In other words, if that's equal to 0, then t has to be equal to 3. And since it cannot be equal to 0, t cannot be equal to 3. And what's the interval notation for that?
Would it be negative infinity to 2? Or since it can't be 3?
No. To
Okay.
3, and the parentheses designates that it can't be 3. It can be every number up to 3. It can be 2.9999999. It just can't be 3.
Bracket?
And then what's the right side?
Negative infinity to infinity.
No, the right side is where we left off at 3 to positive infinity. In other words, that domain means the same thing as t is a member of T, and the only thing that cannot be true is t cannot be equal to minus or to 3. Okay? And the other way you might say that is t is equal to all reals except t cannot be equal to 3. So there's 3 ways to define it. There's interval notation, there's that notation, and there's that notation. They all mean the same thing. They all mean that t can be any number on the number line except 3. Okay? Now, let's consider range. What can f of t be, and what can it not be? And let me give you a clue that you always want to start with what it can't be first. It's because usually it can be most anything. I mean, let's back up a second. If I said y equals square root of x, what can y be and what can y not be?
So it equals the square root of x.
Yeah, if I gave you this function, the domain is x has to be greater than or equal to 0, right? Well, what's the range going to be? Can y ever be negative?
0 to infinity.
Yes, exactly. 0 to infinity. So y is whatever it can be. With this function, it can't be negative. There's no way it can ever be negative. Okay, now let's consider this function up here. Is there any value that f of t cannot be? This is harder. Figuring out range is always harder than figuring out domain. Domain is relatively simple. You're either not dividing by 0 or you're not taking square roots of negative numbers, and that's about all you have to worry about. But range, you have to think about it a little harder. The one value that f of t cannot be is 0. If I try to set that equal to 0, how could that be equal to 0? The only way something is equal to 0, a rational function, is if its numerator is 0. There is no value of t that you can plug in here that would make this thing equal to 0. So it cannot be equal to 0. But it can equal 1,000,000. It can equal 1,000,000,000. It can equal minus 1,000,000 and minus 1,000,000,000. So basically the range is all real values except 0. And if I were to graph this, it's a version of hyperbolic function like that. And you'll notice that the range is negative infinity to 0 and 0 to positive infinity, right?
Yes.
So the graph confirms what we knew. And the key thing in math, and this is worth remembering, is that if I say x squared minus 3 divided by x to the 5th equals 0, and I want to solve that equation, well, the only thing that has to be true is that the numerator has to be 0. Nothing else matters. I don't care what the denominator is. In order for this, what I have circled here, to be an equation, the numerator has to be equal to 0. So my very next step would be setting the numerator equal to 0 and solve it. Okay? Well, the same principle holds in this problem. And that is the numerator is not 0, it's 4. So it's impossible to make that thing equal to 0. But that's the only number it cannot be equal to. If you want to think about how it could be equal to 1,000,000, well, how about this? 4 divided by 3 minus 2.9999999. Well, now the bottom becomes 0.00000001. And when you divide 4 by a really tiny number like that, you get huge numbers. So there's no problem making that big. And likewise, there's no problem making it big negative. In other words, if I want to make it big negative, then I'll let t be 3.01, 0.00001. And now I'll have 4 divided by a negative very tiny number, and that will be like negative 1,000,000. So it is important on these kind of problems to be able to figure out what can I make f of t, and how would I do it? Can I make it infinitely large? Yes. Can I make it infinitely negatively large? Yes. I can make it any number that I want. The one number I cannot make it is 0, because my numerator is 0.
Okay.
All right. We're just doing odds. 7 next?
Yes.
Is 7 a function? Why or why not? What's the test of a function? What's the primary layman's test of a function? But
It crosses the point.
it's got to pass the vertical line test. Can you pass a vertical line through that function and only have it intersect one point? In other words, no, you can't. In other words, here's my function. If I pass a vertical line, it passes through that point and that point. That makes it not a function. All you have to do. Now, how about B? B looks like this. Is that a function?
Yes.
Yeah. No matter where I pass my vertical line, it only connects with the function in one spot. And that's the key. And that means it passes the vertical line test, and that makes it a function. Now, why that's important is a subject for much higher math, but whether stuff is functions or not is important. How about 8a? Is that a function?
No.
How about 8b?
No.
No. These are called relations. 8b is an ellipse. And I can actually write an equation of an ellipse. It's x squared over a squared plus y squared over b squared equals 1. So it's not like I cannot write an equation of that. I can. It's just not a function. It's a relation. It's kind of a composite of two different functions. If you split that ellipse in half, in other words, here's my ellipse. Okay, if I draw a line there, well, the bottom part of the ellipse is a function, and the top part of the ellipse is a function. So an ellipse is actually a combination of two functions, but it is a composite, and therefore it's called a relation, not a function.
Okay.
One of the beauties of calculus and higher math is that they switch to polar coordinates. And when you're trying to analyze the solar system and the movement of the planets, turns out that functions aren't the best way to do it. The best way to do it is with polar equations. And with polar equations, it doesn't matter if something is a function or not. It eliminates the need for it to be a function. And it ends up being a much better system for analyzing the movement of the planets, is with polar equations. I don't know if you've come to those yet, but you will this year if you haven't.
Okay.
Okay, number 9. Express the area and perimeter of an equilateral triangle as a function of the side's length. Well, let me draw the equilateral triangle. And equilateral means 3 equal sides, 3 equal angles. What's the area of this thing? First of all, what's the general formula for the area of a triangle?
Base times height, half.
1/2 base times height. What's the base here?
Half of, or no, x.
No, half of x. You're absolutely right. It's half of x. In other words, the base is from there, excuse me, my apologies. It's x. I was getting ahead of myself. The height is what's hard to figure out because this is 1/2 x, and now we have to solve that triangle to come up with our height. Well, what kind of triangle is that?
Right triangle.
Is it one of our familiar triangles?
Yes.
Which one?
Right triangle, 30, 60, 90.
Yeah, and that's huge because that means we don't have to use trig to solve for that height. Remember what my standard 30, 60, 90 triangle looks like, and why I tell everybody that you're going to need this thing for the next 3 years. Because there are so many triangles that they give you that are 30, 60, 90. So if this is my unit one with proper dimensions, what's h?
That would be x.
Well,
2x. Or no, just x, since it's a half x and then
let's figure out the similarity ratio. In other words, we know it's going to have an x on it, right? But
yes.
the triangle we're looking at is 1/2, 1. So what is this? If I gave you a right triangle whose side opposite the 30 was 1/2 and whose hypotenuse was 1, what would this dimension be? What's the similarity ratio between this and my unit triangle? And when I say similarity ratio, I mean the one thing about similar triangles, and these are similar triangles have the same three angles, is you figure out what the relationship of the proportionate sides are. Well, what's the relationship of these two triangles? Each side on the smaller triangle is what percentage of my unit triangle?
I believe it's half.
Yes, which means instead of square root of 3, it's half of square root of 3. So that's what that dimension is square root of 3 over 2. And now if I go up here and I try to figure out what h is, it's got to be square root of 3 over 2 times x. In other words, you can always have multiples of these dimensions. I call this my unit triangle, but it could be, 2 root 3, 4, and it's still a similar triangle. So the only thing that really matters is the relationship of the sides. Okay, so now I'm ready to solve my problem. The base is x. What's the height?
3 square root of 3 over 2.
X, which means my area is what? And they want you to give the area as a function of x.
1/2 x.
Multiply all of that together and simplify.
Square root of 3 over 2x squared.
Square root of 3 over 4x squared. See why?
Yes.
In other words, I have to multiply numerators and denominators. Okay? And that actually is a theorem in a lot of geometry books where they will give you the area of an equilateral triangle. And it's always square root of 3 over 4 times x squared. And that's not a bad one to memorize, just because the math of figuring it out is actually fairly difficult, as you saw. In other words, it wasn't that easy to come up with the area as a function of x. We did it, and so rather than having to do all of that work every time, a lot of systems will ask you to memorize that.
Okay.
It's worth kind of doing. Square root of 3 over 4 times x squared. All right. How many questions do we have in total here to do? We're about halfway.
Like, there's no set amount, just as many as we can, really, just to review.
Okay. Should we keep doing odds only? It's up to you.
Yes.
Okay, we have enough to keep doing odds only? Okay.
Mm-hmm.
Express the edge length of a cube as a function of the cube's diagonal length. Well, this is tougher still. Express the side length of a cube, we'll call it x, as a function of the length of the square's diagonal. Well, there's the square's diagonal. We'll call that d. Okay? Notice they didn't say the cube's diagonal, because the cube's diagonal would be from this lower left all the way to this upper right. It would be a completely different line than the square's diagonal. So let's figure out what d is as a function of x, or, hold on, let me read the, express the edge length of the cube as a function of d. So we want x equal to something in relating to d. Well, from this picture that I drew right here, what's the height of this cube?
X.
What's d?
Is the diagonal.
Let's solve for it.
Would it be half of x?
No, what we have is a right angle. So we have a right triangle. So use the Pythagorean theorem to solve for d.
Okay, so a squared plus b squared equals c squared. So x squared plus x squared equals d squared.
Okay, so d is equal to plus or minus the square root of x squared plus x squared, or 2x squared, correct?
Yes.
Now, the minus we can throw out because it's a
We
geometry
can't do
problem.
that.
All dimensions have to be positive. You cannot have negative dimensions. So we have d equals the square root of 2x squared. Well, the question calls for expressing the edge length, and the edge length is x, so we actually have to solve that equation for x. What's the next step?
Do the square root of 2x squared.
Not the square root of. We're trying to solve for x. We've got to get rid of the radical sign. How do we do it?
Square.
Yeah, square both sides. So you get d squared equals 2x squared,
Squared.
which means x squared is equal to d squared over 2, which means x is equal to the square root of d squared over 2, which can be simplified further down because that's d. So it's d over the square root.
Square.
And that appears to answer the question as a function of d. Well, x is a function of d there. There's only one problem with that. What's the problem with that answer?
Do we not want it to be in the square root form?
You cannot have an irrational denominator. And square root of 2 is irrational. So we have to rationalize that part right there. How do you rationalize it?
Square.
Well, you multiply it by the number 1. But in this case, the number 1 is going to be the square root of 2 over the square root of 2. That's the number 1. And what you end up with is square root of 2d in the numerator, and now the denominator becomes a rational number. It's okay to have an irrational number in your numerator. It's just not okay to have it in the denominator, okay? So whenever you have it in the denominator, you have to rationalize it. That's what it's called, is rationalizing the denominator. So there is the answer to the first part of this, the first sentence. Express the edge length as a function of diagonal length. Well, we did that. Then express the surface area and volume as a function of diagonal length. Well, what's the surface area in terms of x when you have a cube?
I forgot surface area.
Well, surface areas, you take all 6 areas and add them up.
Okay.
The area of this particular face we're looking at here.
X squared.
Correct. There's 6 of them, so it's 6x squared. Now, what is x squared? Because it wants it expressed as a function of diagonal length. So in place of x, I'm going to write that. So x squared would be 6 times 2d squared over 4. See how I got it?
Because of what we had before.
Well, I just squared this, yeah. In other words, this is what x is equal to. So if I want x squared is the square of the left side of that equation, which is 2d squared over 4.
Okay.
Okay, and then that simplifies, because I'm squaring top and bottom. I've got 6, 4d squared over 16, which is 3/2 d squared. That's what surface area is as a function of d.
Okay.
Now what is volume as a function of x?
Length times width times height.
Which means what as a function of x?
V.
X cubed, right? In other words,
Okay.
the volume of any cube is the length of any side cubed. Well, we know what x is. X is square root of 2d over, what was it? Square root of 2d over 2. So that's what x is. So x cubed has to be that whole thing cubed. And so volume becomes what? What is this amount cubed? What's the numerator cubed?
2D.
First of all,
Because I know
cube
square.
square root of 2. What is square root of 2 cubed? Do it one at a time. Square root of 2 cubed is square root of 2 times square root of 2 times square root of 2.
So
What's that equal to?
2 square root of 2.
2 square root of 2. Okay. So that's what that part is 2 square root of 2. What's d to the third power equal to?
D cubed.
And what's the bottom cubed equal to?
8.
Okay, and all that narrows to square root of 2 over 4 d cubed. So there's the volume as a function of d.
Okay.
So this entire problem is predicated on doing the first sentence. You can't do the second sentence until you do the first sentence. In other words, until you solve for x as a function of the diagonal, you can't do the others because all your formulas for the surface area and the volume are a function of x. In other words, the two that we know are a function of x. Surface area of any cube is always 6x squared, and the volume of any cube is always x cubed. But stating it as a function of the diagonal of one of the squares is a lot harder because you have to solve this to get what x is in terms of diagonal, and then you go from there. All right, let's see. You sent me a second page, right?
Correct.
Now let's stay on odds. Do you have a book that gives you the answer to the odds in the back?
Yes.
Odds only or odds and evens?
Only odds.
Yeah, that's the way most books are. Until you get to calculus. When you get to calculus, guess what? They give you the answers to all of it. Know why?
How come?
Calculus is so hard that a lot of problems you can't figure out how to do them, but if you have the answer, you can almost work backwards and figure out how to solve it. So having the answers is really a vital part of being able to do calculus problems. I might not be able to do a problem if I didn't have the answer, but given an answer, I can usually work out the proper way to do the problem. So it's far more important to have the answers to all of them in calculus.
Okay.
All right, let's look at 13. Consider a point lying on the graph of the line 2x plus 4y equals 5. Well, best way to graph that, because it's in standard format, I could graph it two ways. I could solve it for y, put it into y equal mx plus b format, and graph it normally, right? But
Yes.
it's in standard format right now, and there's actually an easier way to graph something in standard format, and that is just figure out the x and y intercept. Well, the x-intercept is where y equals 0, so the x-intercept's what?
2. Or no, you have to make everything equal 0. So then,
Just make
that'd
y
be-
0 only, and
yes.
then solve what's left. You get 2x
So that would be
5.
2x plus 5, or equals 5, yeah.
So x
So then,
equals, so this point is the x-intercept. Now
yes.
solve for the y-intercept, let x equal 0. That's also a very important concept in math, is when you're solving for either the x or the y-intercept, the other variable is 0 by definition. You can see that when we're on the x-axis, y is 0 everywhere on the x-axis. And we're on the y-axis, x is 0. So what's
Correct.
y-intercept going to be?
4y equals 5. So 5 over 4.
1.25. So there's the line, and notice that I graphed it without knowing slope, which is amazing because usually you have to know slope to do any kind of problem like this. But this is the one time where you can actually graph it quite simply without knowing slope. Okay, so we have a good graph of it. Let L be the distance from a point to the origin. Well, I'm going to put, I'm not sure what they mean, so let me put it on the other side. Let's make L right there. L is the distance from the point. There's an XY coordinate. There's the origin. And L is that distance. Okay? Now, let's proceed. Write L as a function of X.
So,
Hold on a minute. All right. What does L have to do with that line is my question. In other words, that line could be a lot of different things. All right, let's just proceed. Okay? So, first of all, what's the distance of L? What's the distance formula?
x minus x1.
Which in this case is just x. In other words, if this is x1, 0, 0, so it's x squared plus y squared.
Okay.
Right?
Isn't there a slope there?
Well, I'm not sure we need to worry. No, because we don't know where xy is. They just said it was some point xy. Ah. Oh, no, we're okay here. Yeah, they just said it was some point xy. So I could actually have put xy in any of the four quadrants, anywhere on the graph. Okay? But its distance from the origin would still be the same. It would still be the square root of x squared plus y squared, because that's the distance formula between any 2 points. What it really is d is the square root of x minus 0 squared plus y minus 0 squared. See what I'm doing?
Yes.
Okay, because this is the distance between these 2 points. It's just that that point is 0, 0.
Okay.
Okay, so we have D as the distance, and we have it right now as a function of x and y. Well, they want it as a function of x. So what if we go back up here and we solve this thing for y, and then we use substitution? Well, what's y? What's 4y equal to?
5.
5 minus 2x, which means, you see, in other words, I'm just solving this equation for y.
Divide by 4.
So we have 5/4 minus 1/2 x. So that's what y is based on that line. And now, if we go back into the distance function and substitute that for y, we'll have the whole thing as a function of x. In other words, d now becomes the square root of x squared plus, instead of y, I'm going to put this thing in here. See what I'm doing?
Yes.
And now we have the answer. That's actually probably a legitimate answer to give. You could simplify it a little bit by expanding that and then combining the x squared with the 1/4 x squared. So you could simplify that a little bit, but we probably shouldn't take the time to do that here. And L, incidentally, they say let L be the distance from that point. So write L as a function of x means write the distance from that point as a function of x, and there it is. And that was kind of a crazy problem. Because when you first look at it, that distance has nothing to do with this line. In other words, that line could be up here, right? And it would not have anything to do with this distance. But if I want to make this distance strictly as a function of x and not a function of x and y, then I have to use this as a second equation so that I can use substitution and make my distance L be a function strictly of x and not a function of x and y. This is a concept that, let's just review this quickly. If I say y equals square root of x squared minus x plus 2, and over here y equals x minus z, this one, I would say that's a function of x, right? X is the only variable on the right side of the equation.
So
The bottom one,
y equals x minus z.
the bottom one would be a function of x comma z.
So would z be negative x plus 2?
Well, it would be, but that's not, my point is merely to get you to understand
Can you hear me, Mr. Cowan?
function notation means. In other words, if I have only one variable on the right side of the equation, then I have a function of that variable. If I have two variables on the right side of the equation, then it's a function of x comma z, not just x. Can you still hear me, Taylor? I appear to have some audio problems. Can you hear me now?
Yes, I can hear you perfectly.
Yeah, we lost audio for a second there.
Okay.
But that's what this kind of notation means. The reason we use f of x instead of y is because it's more specific. It tells us what variable we're going to find on the other side of the equation. We're going to find nothing but x's. And if I have two variables on the other side of the equation, then it's a function of both variables. It's a function of x and z. The fact that they're being subtracted does not matter. In other words, if it was x divided by z, it would still be a function of x comma z.
Okay.
Okay? So the function notation is more robust, more meaningful, tells you a lot more information about the function. Hold on 1 second, Taylor.
Yeah.
Yes. I tell you what, I'm right in the middle of a session right now. That's okay. My internet was out most of the afternoon. Hold on a second. Let me quickly take a look at my calendar. I am all booked except for an 8:30 half-hour session. You can do that if you like tonight, sure. You want me to go ahead and do it? You want me to do it right now? All right, I will. I'll talk to you then. Bye-bye. Sorry about that, Taylor. Hold on a second.
No problem. Actually, our session's almost over anyway, so it's all good.
Yeah, okay. This was some fairly difficult material here. Yeah, and in fact, I can see that we probably could have put another hour into this, looking at everything that I'm looking at here. Piecewise functions, functions and graphs, greatest and least integer. There's a lot of stuff here.
Yeah.
Meat and potatoes, as I like to call it. But well, I guess we'll get to the rest of it next time.
Okay, sounds good. Have a
All
good
right,
day.
you too. Have a good one.
Thank you too. Bye.